9.8, the Pythagorean theorem. Now the Pythagorean theorem describes the relationship between the legs and the hypotenuse of a right triangle, or the sides of the right triangle. And credit has been given to Pythagoras, a Greek mathematician, for hundreds and hundreds of years, but it was discovered that actually the Chinese came up with the Pythagorean theorem several hundred years before Pythagoras did. Of course, they didn't call it that. And the way this works is that in a right triangle, we have a 90-degree angle, and the 90-degree angle is directly across from the longest side of the triangle called the hypotenuse. And the hypotenuse, again, is the longest side of the triangle. Now, the other two sides of the triangle are known as the legs. And these sides share a relationship with the hypotenuse that if we take the first leg and we square it, and we take the second leg and we square it, we get the hypotenuse squared. Now we assign these legs letters. One leg is A and one leg is B. It doesn't matter which. The hypotenuse is always C, and we get A squared plus B squared equals C squared. This is the Pythagorean theorem. And we can show that that's true if I take a right triangle with the legs of 3 and 4 and a hypotenuse of 5. A squared plus B squared equals C squared. I'll assign the legs A and B. It doesn't matter which is which. The hypotenuse is C. It is always directly across from the right angle. And I say 3 squared plus 4 squared is equal to 5 squared. 9 plus 16 is equal to 25. 9 and 16 is actually 25, so this is true. And this is true for any triangle. Frequently, we're given random triangles and we have to find the missing side. So for example, if I'm given a triangle with a side length of 13 and another side length of 4, I need to find the missing side. Well, 13 is across from the right angle. That makes it the hypotenuse. So I can call this leg A and this leg B, and this is C. And so I'll have A squared plus B squared equals C squared. So that's 4 squared plus B squared equals 13 squared. That's 16 plus B squared is equal to 169. I subtract 16 from both sides. B squared is equal to 153. And then I take the square root of both sides. So B is the square root of 153. Now I want to see if I can simplify this. So I'm going to look at 153. It's not even, so it won't divide by 2. It doesn't divide by 3 either, because the sum of 1 and 5, oh, no, I'm wrong. 1 plus 5 plus 3 is 9, so 153 will divide by 3. So I'll divide it by 3, and that gives me 51, which adds up to 6, so it also divides by 3. And that will give me 17. So my missing leg is 3 times the square root of 17, because I had this pair of 3's. So let's try another one. If I have a leg length of 27 and another leg length of, say, 10, and I'm missing this long side, that's C. So again, it doesn't matter which you sign A and B, but C has to always be the hypotenuse. So I have A squared plus B squared is equal to C squared. 10 squared plus 27 squared is equal to c squared. 100 plus 27 squared is 729 is equal to c squared. So that's 829 is equal to c squared. Now to solve for c, I'll need to take the square root of both sides. So the square root of 829 is equal to c. Now I need to figure out if 829 is reducible. It does not divide by 3 or 7 or 11 or 13. Actually, let me tell you a trick. If you plug into the calculator and you take the square root of 829, the square root of 829 is 28.79, etc. So this is about 28.792. We need to check every prime up to 28. It won't be any number larger than that. So if I take 829 again, I've divided by 3 and I tried 7. I tried 11. 13 it didn't divide by. The next prime number is 17. It does not divide by that. Then 19 did not divide evenly by 19. And 23 it does not divide evenly by. The next prime is 29, which is greater than the square root. And so therefore I know that this is not simplifiable, so I can leave it just as c is equal to the square root of 829. Now the Pythagorean theorem is useful for application problems. So for example, if there's a window and it is 15 feet up a wall, and you have a ladder, and it is 17 feet long, and you want to lean it up against the wall, you can either know how far from the wall you want to have it and see if the ladder will reach, or we could say how far from the wall do we place the ladder. Okay, well if we draw that picture, we have our wall, and we have our window, and this is 15 feet, and we have a ladder, and that is a 17-foot ladder. We want to find out what is this distance here. Well, that makes a right triangle. The wall and the ground shall be at 90-degree angles to each other. So we call this A, we call this B, we call this C, and we say a squared plus b squared equals c squared. So 15 squared plus b squared equals 17 squared. 15 squared is 225. 17 squared is 289. So I subtract 225 from both sides. And I get that b squared is equal to 64. Now if I take the square root of both sides, b is going to be 8. So we would put the ladder 8 feet from the wall for it to be the same height as the window. Another example that people have used, if I am flying a kite, and I have my kite up here in the sky, and I know that I have 110 feet of string. Okay, and I have a friend go and they stand directly underneath the kite. and we measure, and they are standing 75, well, let's do 50 feet away. We want to know, how high is my kite? Well, again, that's my hypotenuse, so I call this A and B and C. So A squared plus B squared equals C squared. 50 feet squared, unknown, and we have 110 squared. 50 squared is 2,500 because we square the 5 and double the zeros. Okay, subtract 2,500 from both sides. And B squared is going to be 9,600. Okay, we'll take the square root of both sides. And B will be, let's see, if I take the simplification route, I have 96 times 100. And 96 is 2 times 48. And 48 is 2 times 24, and 24 is 2 times 12, and 12 is 2 times 6, and 6 is 2 times 3. I have a perfect square here, and here, and here. So I'm going to bring out 10 times 2 times 2, and I leave behind 6. So I would have 40 times the square root of 6. But if I wanted to know an approximate value, this little symbol here means approximately, I would put into the calculator 9,600 and take the square root of it, and I would get 97.97 feet. So roughly 98 feet high up in the air with the kite.